Hello and welcome back to our data structures and algorithm series. In this video, we want to implement the stack operation, but just before we jump into the code, let's have a look at how this really works using a linked list. So we add and remove things from the head of the linked list, or if you want, you can call it the first node of the linked list in order to implement really the stack operations. So we can only add or remove from the head, from the very first node of the linked list. So in this case, we want to do a push, which is adding another node on the head of the linked list. Now, the first thing you have to do, which is not captured in this particular visualization, is to check the head. So if it is none, then you simply need to set the head as the first item of the stack, or really the first item of the linked list. So that is not captured here. Here we're just assuming that you already have other items in the stack. In this case, this is the very last item in the stack, then this is the top. So this is the top of the stack, and now we want to add another item. So to do that in a linked list is quite easy. It's an O of 1 operation, because we simply have to create that particular node. Then after creating that node, we point that node to the head, which is pointing to the node that was on the top. Then after that, we simply delete what has been saved on the node and point the head to the node that we just created. And now the node A becomes the top of our stack. So that is the push operation, really, using linked list. It's an O of 1 operation again. Then we have the pop operation. So pop is just deleting. So to pop is even easier, because you just need to again check if the list is empty, because you cannot if the stack is empty, and if it's not empty, you simply point the head to the next node, so to head.next. Then of course you delete that particular link, and the garbage collector is going to free up that memory space, because no other object is referring to that particular node. So that is how we delete from the top of the list. So if we wanted to delete node B, we will do the same thing. So let's go ahead and do the coding. Okay, so we can create the file. We can call this stack linked list operations.py. Okay, so we simply need to begin by creating the node class, which is going to create for us the nodes. And of course, as we did, we need to create the initialization function, which is going to take self and the data for the node. Then we can do self.data is equals to the data that we have passed. Then we can do self.next is equals to none initially. So that is the very first class we need to create. Then you remember we were also creating the linked list class, but this time, because we are creating a stack, or we're implementing a stack, we just want to call this class stack. Then of course we're also going to have an initialization function. Remember, it's 2 dashes, which is going to receive the self there. Then we are simply going to say self.head self.head is equals to none. So anytime you create an object from the stack class, it will create a head that is pointing to nothing. Then we can implement a function to check if the stack is empty. So to do that, we simply do def. We can call it is empty like that. Then we can do return self dot head is none like that. So if the head is empty, then this condition, if the head is none, this condition is going to be true. Otherwise, it's going to be false. Okay, then we can implement a function, to push data to the stack. So this is going to be called push. So self, then it's also going to receive the data that we pass it. So the first thing we need to do here is to create a new node. So we call the node class, and we pass it that particular value that we have just received. Then we need to check so check if the stack is empty. So we can do if is empty. Oh, this is supposed to be self.empty like that. So if it's empty, we just want to say that the head, we want to point the head to the new node that we've just created like that. Else, that is, if it's not empty, we want to say that the new node dot next should point to the head. So self dot head like that. Then the head, self dot head, should point to the new node that we've just created. So of course, that is how we implemented adding a node on the head of a list. So that particular function is done as it is. Then we can do the function to we can do the a function to pop data from the stack. Okay, so can do def pop should receive that. Then we can check if self dot is empty. We want to check if that particular function is empty. So if it's empty, we want to print the stack is empty. The stack is empty. Otherwise, we want to remove whatever is on the head of the list. So we just want to create a variable here called pop data. Then we point it to self.head.data like that. So that is going to hold whatever is on the very first node. Then we can point self.head to self.head.next like that. So now we are pointing the head to what was the second item in the stack. Then after that, we can return the popped data like that. Okay, then we can also do a function to pick data from the stack. So this should be def pick, and this is simply supposed to check if self dot is empty. So if it's empty, we again want to print the stack is empty. Else we want to we just want this to return self.head.data. Okay, so I think that is it. Those are the only functions we need there. So we can get out of the class and create a stack. You can call it anything you want. So we create a stack there, and then we can do stack dot push to push data into the stack. So we can pass it, for example, the number 1, and then we can do stack dot pick to see what we've got here. So this is just going to return the data, so we better print it. So print. Okay, so I can save and run this. Great. So you see it's returning a 1. So we are good. We can also maybe do 2, 3, save, should return a 3. Great, you can see down here on the terminal, it's actually returning a 3. Then we can try to do stack.pop and see whether it's working. So stack.pop, just like that. We don't need to pass anything to that function. So if we run it, good, now we have 2 at the top. What if we do that again? So just duplicated that line, now we have 1. What if we duplicate that again and again, save it? Okay, so good, we should get the stack is empty. The stack is empty because it's actually empty. Okay, so thank you so much for sticking to the end. That is the end of this particular lesson on implementing stack operations using linked list. Just as a reminder, all these operations are actually O(1) operations when it comes to the time complexities. So thank you so much. In the next video, we should be implementing the queue. We should learn about the queue data structure. So see you in the next video. Bye bye for now.